Hopefully I'm recording. Am I recording? I think looks like it. Okay. Looking at videos on the Sapphire project. Very impressive stuff. Well, I kind of made something a long time ago in the 80s when I scored out some plasma capacitors at 500 joules, 25,000 volts each, as well as, how many microfarads? 2 microfarads each. And a very heavy, they weighed about 125 pounds each, had 16 of them. Then I had one that was 1 ton, low inductance type, rated for 60,000 volts, 5 microfarads as I recall. I think it was 1.5 for the 120 5 pounds ones, and low inductance, 500 joules each, rated for 25,000 volts each, as well as a 400,000 volts direct current transformer. I required all this stuff through Rendell Parrot Electronics on 4th Avenue, Vancouver, British Columbia. Eventually I got them all and made corona suppressant balls, rings, as well as I also got tungsten tipped ignition systems from Aircraft of Satellite Electronics on Maine, and proceeded to build corona rings, and eventually built the whole structure, which we'll see in a minute. Okay, so here we have I got it up, tuned everything with induction coils, all the capacitors in series parallel, loaded them up to about 100,000 volts direct current, and discharge them like this. This is what you'd see, extremely bright. And on occasion, I do experiments by putting on the terminals some aluminium wire, copper wire, steel wire, thin, of course, and on occasion these would vaporize into a plasma bead, kind of like bead lightning, very bright. They lasted maybe, I think the longest was a couple of seconds. These I actually got to go down a tube, a plastic tube surrounded by 1, 2, 3, 4, 5, 6, 7, 8, 10, I think 10 to 8 corona rings are around attached to the plastic tube. And then I had magnetic fields from using old traveling waveguide tube, variable electromagnets. Simple stuff you get at RP Electronics, as well as Satellites Electronics on Main Street. So I substitute the tube with an iron bar, so I could tune all this stuff. And I got the plasma beads to go down the tube, and they hit certain things and go do a little pop. So on we go. This is part of the video that First News, CK View Television for Canada filmed. Very bright, extremely bright spark. It's well recorded by McDonnell Douglas Aerospace, George Jack Houck, 2 days of filming. But this is First News. But I have to upload the video someday. It was uploaded on YouTube until YouTube knocked my channel off, which I like doing for some unknown reason. Okay, on to the next one. This is more of a directed system, suspended by insulated cables, tri-coil arrangement, electrostatic and high voltage power conditioning gear. I won't go into all the details on the micro Henrys and all this kind of stuff and design system, but mostly made of aluminium, as well as variable roller inductors, as you can see on the left. It's vintage radio stuff. Okay, let's go to the next one. So this is again a screenshot of the gap, spark gap, just forming the discharge. You can't really see the corona rings and plastic tube. It's kind of filmed the other way around here. Also used glass balls. I was lucky to find those in a secondhand store. They're round glass balls, about just under 4 inches, with a hole through them, and I used those for static accumulation and power conditioning, and because all this stuff is kind of simple, but you can have to actually shape the electrostatic field and use magnets and geometric patterns like round balls and corona rings, and to add or take away capacitance in certain areas. It's fun. Well, here's another screenshot of the discharge. Tell me what you see. More screenshots of Grant Frederick's video for CK View television on my plasma gap generator. So this is what Grant Fredericks filmed for First News. And that's the same. Okay, screenshot of the discharge itself. Would radiate out quite a bit and affect things at a distance, which you'll see in a moment as they filmed some minor effects happening with this giant spark gap. Using those capacitors I mentioned, low inductance, plasma capacitors, and we'll just get to, I have actual videos and pictures of those capacitors and them lined up. Again, 125 pounds, maybe 150 pounds each, 16 of them, with one big one I used for ballast. It weighed about 1,000 pounds, and there's videos of that. I have that somewhere in videos. 60,000 volts direct current, low inductance, 5,000, it was 5,000 joule type. The other ones were 500 joules each. Plasma capacitor, University of British Columbia, Canada, British Columbia. So what you're seeing here is the energy from that spark gap inducing energy into objects on the test table. Cool, huh? Now we're recording. This is another angle of something else in high voltage I was doing. But I always had this snapping gap in my experiments, different levels of magnitude, and the biggest is the one that you're seeing here. And let me go to another picture. So this is the biggest one I had, and I expanded upon that. I guess if you were to add up the total weight of all the equipment that was used to generate this, it would be probably 3,000 pounds, maybe. Rough guess. But it's the biggest system. And it took a lot of work to put it together. The cost was ridiculously hardly anything. Again, it was low inductance, 500 joules, 25,000 volt plasma capacitors from the University of British Columbia. Then I built a special holding table for them, put all 16 in series of parallel, and added the ballast one, which is 5,000 joules at 60,000 volts direct current, weighing at about 2,000 pounds, or give or take. and that was all powered by a 400,000 volt Siemens X-ray transformer at maximum, I think it was 2 milliamperes at top, 400,000 volts direct current, which divided up series parallel, and then it would produce this every 59 seconds, a big snapping gap, boom, boom, which I found it very useful in adding argon, xenon tubes, gas stuff between these two terminals, you see here, producing very brilliant kind of light. That kind of burnt my face a few times. The discharge gap is tungsten, by the way, used in aircraft ignition systems, which I bought from Satellite Electronics on Main Street's military surplus. That's pretty cool stuff, and I'd bolt onto these gaps different metals, and they would vaporize into round beads of lightning, which, if you call it lightning, bead balls, very bright, white bright, hard to describe it, almost like carbon arc brightness. Anyway, these have got to travel down a plastic tube that was surrounded by corona rings, that was surrounded by back ends, traveling wave tube, electromagnetics, that were powered 110 variable to variacs, anywhere from 25 volts AC or DC up to 150 volts. Tunable type, 3 of them approximately. Weighed 15 pounds each, copper, basically copper electromagnets, because I'd insert where the traveling wave tube went an iron bar, which I roughly remember as a little over an inch in diameter by a foot long, positioned different angles. Electrostatic generators producing static on the corona ring surrounding the plastic tube would guide these balls in certain directions down the tube and out into the environment. Some would hit something, some would just simply disappear. It was an interesting thing to me to do. It was kind of fun, and that lasted some years. Then I moved to 560 Cambie Street, Vancouver, British Columbia, and set it all up again, and got to use it in basically the same format, but not much video was covered except for news stories and that kind of stuff, because we had to move out of the building and so on and so forth. But anyway, you can also do curious things with glass containers with different gases inside of those containers. Like, I mean, it's easy to get these things in surplus in Vancouver. It's an amazing place to get anything, really. So you get a couple of electrodes heated into Pyrex, Malibu glass stuff, and you get these little argon bottles or neon bottles or xenon bottles. Now, much later on, I found these things on warships. They were ignition systems with the gases already in them. But tungsten, I find, is excellent for producing a very reliable spark like this. And you have to be careful with these kinds. You gotta know what you're doing. I always carried around a plastic rod with a chain on it to discharge all the different capacitors. And when I moved to 560 Cambie Street, George Lissicase wired one capacitor in reverse, which resulted in a massive explosion in that laboratory, which was covered up by the British Columbia environmental government folks, who just had to come down and investigate. Anyway, that's some of my weird stuff with plasma. Later on, I got smaller plasma balls and things, which I took videos of with Grant Romand and Thomas Messer. Anyway, I'm going to shut up now and call it a day and upload this. Thank you. Take care and good luck.